We now turn to a hypothesis testing problem involving a median. Before, in 1970, the median height amongst women aged 18 to 24 in the U.S. was 63.5 inches. To test if this hypothesis this median remains true, a sample of 20 women were sampled and the heights are shown. Does it appear that the median heights are now greater than 63.5 inches? So to do this problem, we will let m be the current median and let pi be the probability of having a height above 63.5 inches. The null hypothesis would be that the median is 63.5 or that pi is 0.5. To explain why those two statements are the same, let's just draw a number line here. Suppose that 63.5 is here, and suppose this is equal to the median. If that's the median, then half the data lies above and half the data lies below the median. So the probability of being above 63.5 inches would be exactly 1/2 if indeed the median is 1/2. The alternative hypothesis would be that the median is something bigger than 63.5. So that means half the data lies to the left of m and the other half lies way over here. So that means that if I take a look at the probability of being above 63.5, I get half the data over here and then some, this whatever is between 63.5 and m. So the median being above 63.5 for this particular problem would mean that pi is greater than 0.5. So that's just a quick cartoon sketch to kind of see why those statements about the medians and pi are correct. Okay, next thing we do is to ignore anything that is exactly at the median of 63.5. So this one here is exactly 63.5, so I'll ignore that. And there's a 63.5 here, so I'll ignore that. Now I count the number of heights that are above 63.5. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So of these sample here, we have 15 that are above 63.5. So that I have a sample of size 18, of which 15 have heights above 63.5 inches. So my test statistic, in this case, will be the probability of something this extreme or more extreme. So k greater than or equal to 15. So that would be 1 minus the probability that k is less than or equal to 14. Then using Excel to make this computation, we have 1 minus binom dist 14, 18, 0.5 true. And that is significantly less than 5%. So based on the small survey that's been taken, we have a p-value that is less than 5%. So our conclusion is, based on this small sample, is that we reject the null hypothesis. We have reason to think that the median is now larger than 63.5 inches. So to do this problem, we've used the median to convert it to a question about probability, and then use the techniques of hypothesis testing to study that probability.